This is Module 12, Lesson 5. This lesson is going to focus on interference, which is how waves kind of interfere with each other, for better way of putting it. Sometimes they interfere well, sometimes they don't. Whenever two waves travel and they interact with each other, sometimes they will overlap each other, and we call that superposition. So the principle of superposition basically says that anytime you overlap two waves together, we can add up any parts of the waves that overlap with each other. So that's the amplitude. The total amplitude of the waves is the sum of the amplitudes. So in other words, if we have two waves that overlap and, like there's wave one, and we take a second wave, and we overlap a smaller wave with this one, like maybe they go slightly together, we can overlap them to make a grander, like we'll end up with a slightly taller wave all the way across because we're adding up the red and the blue together to make the green wave. Okay, so here's some better drawings. Whenever we do this and they build each other up, that's called constructive interference. So it's whenever two waves with the exact same frequency and phase, that means like they have a crest where the other one has a crest and there's a trough where the other one has a trough. Whenever they overlap perfectly, you end up with something called constructive interference. Okay, and they make larger crests and larger troughs. So here we have two waves, they overlap perfectly. So we end up with a much taller, and if you can look at my graph paper in the background, you can see how it went from like 1, 2, 3, 4 blocks high for each of them to being, approximately double that. Whenever they overlap and their phases are opposite, that means like where this one has a crest, this one has a trough, when their frequency is exactly the same, then they will completely cancel each other out. That is called destructive interference. And in this case, it'll actually completely cancel and you end up with a perfectly flat line because they overlap with the same frequency but opposite phase. It's also possible that they can overlap with not complete same frequency or same phases, and then you just end up with like a funky pattern. So we need to talk about what happens whenever a wave hits a fixed boundary versus a free boundary. So here's what I mean by fixed and free, okay? And I'm looking at the examples that I have for you. Let's see, this is on your paper. So whenever we have a free end, what it means by free end isn't this is just laying on the floor and that there's nothing on the other side of it. So I'm gonna have to edit your pictures a little bit. I want you to picture like maybe a pole and a ring on this. So in other words, the rope is attached to this pole. It's not truly free, but it is free to move up and down. Like it's not in a fixed position. If it has a fixed position, what that means is we're pretending that there's a wall or a pole here, and this is actually tied to it, like maybe it's knotted to the actual pole that it's around. Maybe it's tied to a doorknob. Someone's holding on to it and not letting it move, whereas this one is free to move. This rope can actually move up and down on the pole, or I don't know what else would have it tied to, but it's free to move about. It's not fixed in place. So these are actually the first two pictures that you have on your paper. And what we're going to do with it is we are going to fix it so that your first one, we are just simply looking at two waves that are moving through a rope, and we're actually not worried at all about whether or not there is a free end or fixed end. Just what would happen as these two waves go past each other within this medium. What would happen as they go past each other is that eventually they're going to overlap so that you have the crest and the trough together, and that would be perfect destructive interference. This one's going to move to the right, this one's going to move to the left, and they're going to cancel each other out at this point. So we would end up having destructive interference, and the pattern that it would make is just a flat line, okay? what would happen if it was a free end this time? So we have these waves that are moving towards our boundary here, but it's a free boundary. We have this end of it that's able to move up and down. Well, one of the things that you need to know is that whenever you have a free end, it's this point right here, whenever you have a free end, the reflected wave, what this is going to do is it's going to hit this, it's going to take this energy and it's going to move it down the pole or the post, and it's going to send it back exactly the same, but it's just going to change the direction. So it's going to rebound back down the rope in the opposite direction. It's going to stay a trough as far as how we can see it. So you should kind of understand, hopefully, that this little pulse is going to hit first. It's going to rebound and come back, and then it's going to cross over with this one. They're going to overlap each other. And when they overlap each other, since you're overlapping yet again a crest with a trough, we are going to yet again have destructive interference and a flat line. Okay. Now, here's another example. We don't have anything on here, so I'm not concerned with what they're going to do when they hit the boundary. We just know that they're simply going to overtake each other. They're heading towards each other. They're going to overlap, so we're going to get both of them overlapping here in the middle, and what that'll make is an extra tall one. That is going to be constructive interference. And what you're going to get out of it is a doubly tall crest for just a moment, and then they'll part ways, and this one will have moved on to this side, and this one will have moved on to that side, and away they go from each other. Okay. Now, how are these going to overlap? This time we do have a fixed boundary. This is, we're assuming like it's knotted in place, it's attached to this brick wall. It is not free to move up and down the wall, a pole, a post, or anything like that. It's stuck in place. What I told you on the previous slide is that whenever you have a fixed boundary, the wave will reflect and it will invert its amplitude. What that means is that it is going to come down here. Whoops, not what I wanted to do. It is going to come down to the end, and it is going to flip itself the other direction. And somehow I've lost my pen. There we go. It's going to come down here, and when it hits, it's actually going to turn the other way. It's going to head to the left, and it's going to head back as a crest instead of a trough. Okay, so this one's going to hit first, and then this guy is moving on down to the right. Then they're going to overlap, with this one being a crest and this one being a crest. So it kind of turns into this situation. So when these overlap, they will overlap constructively with a doubly tall crest, and then they will move on about their ways. Then this one will hit, and it will return. So on the return loop of this one, once they've both returned, this one right here will be returning left that way, and the one on top will return upside down, going the other direction. Okay, but they've overlapped before they do that. What about this one? Well, we know that this one's going to hit first. So when it hits, it's going to hit, and it's going to invert heading this direction. Then this one is traveling down. So by the time they overlap, they're going to overlap as a crest and this trough. So these will overlap destructively when cancel each other out for just a moment. What about these? So we're assuming, again, a free end. So this has something that is free to move up and down. So what we need to know is that when it has a free end, it doesn't invert. It just heads the opposite direction. So this one's going to turn around when it hits, and it's going to go back while this one's heading towards it. What's that going to do? It's going to cause them to interfere constructively with an extra tall crest, and then they'll move on their various ways. This one will eventually follow it back in the same direction. That's the type of thing that you need to know with the wave patterns, is how they'll interact with each other with free or fixed ends. And then we have a couple of cases where I wasn't concerned with that. They'll overlap before they get to the boundary and turn around and come back. So now it's practice time. It's time for you to move on from here. I have a worksheet for you to do that actually includes you doing some numbers with it. So what do you need to do? You need to see if you can understand how the waves would interact with each other, whether they would interact with each other constructively, destructively, would they add up? Now this one actually has numbers with it, so you actually have to read the graph and do the math. I think it's pretty simple for you to add it up. The first thing is actually done for you on these, like you're given some examples for the first dot. So put numbers with it, and if you have questions, feel free to let me know.